Today we are starting a new chapter on radicals, and the first section that we're going to talk about is called radicals and exponents. Okay, so exponents are related to radicals. Okay, so that's the most important thing to know, is that radicals and exponents kind of go together. And we've studied exponents, and we kind of know what radicals are. So today we're just kind of showing what their relationship is and how we can use that. Okay, so let's review the properties of exponents that we learned. The first one is the product property, which says that if you have a base with an exponent times the same base and an exponent, you just add the exponents together. Then you have the quotient property, which says that if you have a base and an exponent divided by that same exact base and an exponent, you just subtract the exponents. Then you have the power property, which says that if you have a base to a power to another power, you just multiply those powers, right? You just multiply the exponent. Then you have the zero exponent property, and that says that anytime you have a zero as an exponent, the answer is 1. Then you have the negative exponent property, which says that if you have a negative exponent, then you need to take the reciprocal. So basically, your base is going to move to the other side of the fraction line. So if your base was a whole number, it's going to be going to the denominator. If your base was in the denominator, it will move up to the numerator. And when it does that, when it makes its move, your exponent will become positive. Then we have a power of a product. And so that says that if you have a product, right, a number times a number, an x times a y, and outside of that you have a power, then you're going to distribute that power. Then you have a power of a quotient, which is the same thing. You have a quotient, something divided by something, and the whole thing in parentheses is to a power, then you distribute that power. All right, so let's take a look at the product property, okay? So in this example, we say that 2 to the third times 2 to the fifth. Well, using the product property, that means we can do 2 to the third plus 5, okay? So what we want to show is, does it work, okay? If I can, and instead of saying 2 to the third times 2 to the fifth and plugging it in my calculator, if I first do 2 to the 3 plus 5, well, 2 to the third is 8, and 2 to the fifth is 32, and 2 to the 3 plus 5 is 2 to the 8th. Okay, well, 8 times 32 is 256, and 2 to the 8th power is also 256. So it does work. We just proved that the product property works. All right, so let's look at radicals. We're going to claim right now that the square root times the square root, so the square root of a number times the square root of the number, if you multiply them together, you just get the number. Well, how does that work? Like, is that true? Like, can we prove that? Yes, we can. Because the thing is that when we say the square root of 3, we're really saying 3 to the 1/2. So 3 to the 1/2 times 3 to the 1/2. Well, the product property says that you add those exponents together. So 1/2 plus 1/2 is 1. So 3 to the 1 is 3. So that's why it works. The numerator stays with the base inside the square root, and the denominator moves out of the way into the index. Okay, so let's see an example of this. We have x to the 3/4. And if we want to put that into radical form, we need to get rid of the denominator. So the denominator, the 4, is going to go into the index. And then it's going to become x cubed inside the root. All right, so how do we go from radical to exponential? Number 1, we factor numbers into primes. Factor numbers into primes. Number 2, we write in exponential form. 3, we simplify all fractions. So let's look at an example. We have 4 roots of 64, x to the 5th, y to the 3rd. So the first thing we want to do is we want to change 64 into a prime number. So I think if I take 2 and I keep doing powers of 2, will I ever get to 64? Well, 2 times 2 is 4, and 4 times 2 is 8. So far I've got 3 2's. And 8 times 2 is 16. Now I've got 4 2's. 16 times 2 is 32. So now I've got 5 2's. And 32 times 2 is 64. Now I have 6 2's. Okay, so I did get to 64. Yay, so 2 works. So 2, I had 6 2's. So 2 to the 6th power is the same as saying 64. So I'm going to replace 64 with 2 to the 6th power. So that means I'm going to take that index and I'm going to put it in the denominator of each exponent. So the 2 to the 6th power is going to become 2 to the 6 over 4. And then x to the 5th will become x to the 5 over 4. And then y to the 3rd will become y to the 3 over 4. So I'm looking at my answer choices. I've not seen 2 to the 6 over 4, but 6 over 4 reduces to 3 over 2. So that means that our answer is going to be number 2. All right, next one. So I have 16, so I need to write that as a prime. So let's think of 2. 2 times 2 is 4. Okay, so far I got 2 2's. 4 times 2 is 8. Now I've got 3 2's. And then 8 times 2 is 16. I've got 4 2's. Oh, and 16 is the number that we're trying for. So 2 to the 4th power is the same as saying 16. Okay, so then I take my index, my 3, and I'm going to put it as my denominator. So it becomes 2 to the 4 over 3, a to the 3 over 3, which is the same as just saying a to the 1, or a. Then I've got b to the 2 over 3, and c to the 5 over 3. So that answer would be number 3. All right, so again, the denominator is going to be in your index, right? The denominator goes into your index, okay? So if these are your numbers, 2 to the 3 over 4, a to the 1 over 4, the number that's going to go in the index will be the 4, right? Because that's the denominator, okay? So that will go into the denominator, or into the index, leaving you 2 to the 3rd and a to the 1, which is just a. Okay, and 2 to the 3rd is 8, so we'll go ahead and write 8. So now we've got 4 roots of 8a. So we're changing from exponential form all the way to radical form. So we changed from exponential to radical. So what about this? We have 6, 3, and 2 as our denominators. What's going to go in the index? Which one? Well, we had to find a common denominator of those denominators, 2, 3, and 6. So to get a common denominator, you're looking for the least common multiple. So the least common multiple of 2, 3, and 6 would be 6, right? And then once you have a common denominator, then you can write it in radical form, okay? So let's look at an example. This one we have 2, 4, and 2. So our least common denominator would be 4, which means that 4 would be in the index, okay? 4 would be in the index. So we know that the answer is not 1, right? It's either going to be number 2 or number 3. But if I make 4 my least common denominator, I just can't change the denominator and be like, oh, let's just change it. I have to change the numerator. So that 3 to the 1/2, if I change the denominator to 4, will become 3 to the 2/4, right? Which means it'll be 3 to the 2nd power when I remove the 4 and take it to the index. And 3 to the 2nd power is 9, which I believe number 3 has a 9 in it. Okay, so let's check one more. X to the 3/4, well, when the 4 moves to the index, it just leaves me x to the 3rd. Okay, number 3 has that. And then y to the 3 over 2, when I change my denominator to 4, that's going to become 6 over 4. And when I move my 4 to the index, it'll leave me with y to the 6, which is also what number 3 has. So our answer is number 3. All right, let's just practice simplifying some exponents, right? So 2 to the 3/2 times 2 to the 1/2. Remember, we just add the exponents, right? So 3/2 plus 1/2 is 4/2. 4 halves is just 2. So we've got 2 to the second power, which is 4. Then we've got that nonsense to the 0 power. I don't even have to worry about what that nonsense is because anything to the 0 power is 1. Okay, now I've got 2 to the 3 halves divided by 2 to the 1 half. So remember, this is the quotient rule, so we subtract 3 halves minus 1 half is going to be 2 halves, which is just the same as 1. So we have 2 to the 1, 2 to the first power, which is just 2. All right, so this one, 3 to the 3/4 to the 4th power. So remember, this is the power of a power, so we multiply the exponents, right? 3/4 times 4 just becomes 3, and 3 to the 3rd power is 27, which is answer number 1. All right, 6 to the -2. So this is the negative exponent. It doesn't want to be negative, so it's going to move, right? It's a whole number, which means that it's going to move to the denominator. There's nothing left in the numerator, so we have to write a 1, okay? And then once it moves to the denominator, it's going to become a positive 2, so it'll be 6 to the positive 2, and 6 to the positive 2 is 36, which means our answer would be number 2. All right, your turn. You're going to do 7.1, 2 through 6 evens.